Hi everyone. Today we're talking about this amazingly interesting problem, which is finding the shortest distance between a point and a line on a 2D plane. So here is the normal form of a line. And derive it a little bit, we can get this function. And it is pretty obvious here that the slope of this line is negative a over b, which is, as we write it as a vector, will be b dot negative a. And now we can, so when you think about the shortest distance, what will be the first word that pop up in your mind? I suppose it's normal line, right? We have to somehow find something about normal line of this line A to find the shortest distance. And it's actually pretty easy for us to find to find a slope for this normal line. And we can also write it as a vector, which will be a dot b, because we used a pretty awesome formula here, which is the dot product between any two vector can only be zero if they are perpendicular to each other, which in this case it is. The normal line is perpendicular to the original line A. And now we can just pick a random point, a completely random point on this line, and we can name it P2, which has the coordinates of x2, y2. Yeah, this is the vector of the normal line. And the P2 is here, x2, y2. And so, yeah, now there's another really important vector here, which is P2, P1. So P2, P1 is a vector. And how do we write it? It would simply be x1 minus x2 dot y1 minus y2. So now we're going to introduce one of the really important formula for this video, which is the projection formula. Com y no. So this equation, this formula basically tells us what is the length of vector b that projects in the direction of n. A dot b, no, n dot b over the length of n. Can be here, yeah. This will be our normal vector AB. So as we know, n dot b is equal to the length of n times the length of b times cosine theta, the angle here. Since we're choosing a random point on this line, we can't say the angle for sure. We don't know this angle. So we have to use the formula here, which gives us, now we can plug things into the equation. It's A dot B dot x1 minus x2, y1 minus y2 over the length of n, which is just a squared plus b squared under a root. And we're really close to the answer here. However, there's one really important derivative step we have to do here, is that as we know, based on our assumption, P2 is a point on this line. So it also obeys this equation, which means ax2 plus bx2 plus by2 is equal to negative c. And as we expand the expression here, it would actually give us this equation, ax1 minus ax2 plus by1 minus by2 over the length of the vector n, the normal vector. And these two terms here is just the negative sum of the two terms here, which would actually equal to c. So the upper portion of this whole fraction will be ax1 plus by1 plus c over the length of the normal vector a squared plus b squared under root. And since we're calculating the distance here, and distance is a scalar, so it doesn't really matter which direction it points. So we can add an absolute value symbol here. We take its absolute value. And this is our distance formula. It is a really interesting problem, I suppose. And it will become really easy if you do it with vectors. And I hope that you find this video helpful, and please leave a like maybe if you think it's that helpful, and see you guys in the next video. Thank you so much for watching.